So this is assignment related to the work energy power. We were discussing the questions related to the topic of work energy and power. So in question 4, there's a wind turbine and it's used to generate electricity. So we have a wind turbine. We have to identify the useful energy. So the wind speed is 10 meter per second. Example, if this is a wind turbine, the wind speed is 10 meter per second. And the power input into a wind turbine is 3.2 kilowatt, or we can say 3.2 into 10 power 3 watts. We have to calculate the mass of air per second, like every second, how much air is passing through, what is the mass of air passing through every second, that we have to calculate. We know that kinetic energy, basically, this is the input energy, and what will be the input power? Input power or power is equals to energy. And in this case, what is the input energy? Because that's a kinetic energy divided by time. So we can say input power is equals to kinetic energy divided by time. What is the input power? That is 3.2 kilowatts. So 3.2 into 10 to the power 3. Kinetic energy is half m, and v square. V is the speed, the wind speed, which is 10. So that square divided by the time t. What we want in the question, if you see they mention mass per unit time, so we need this factor m by t. So if we need this m by t, the other factors will move. So it will be 3.2 into 10 to the power 3, not 5, divided by 0.5 into 10 square. So what is m by t? Mass divided by time. When we solve this, it will come out as 64, and the unit, because the mass is kilogram and time is second, so it will be 64 kilogram per second. Is it clear? Discussion how we work out how much mass of the air is passing every second. Another question related to the work done. A simple catapult consists of a rubber strip. So the catapult is there. These are the fixed point. A ball is placed, which is connected to two fixed points as shown. It has used to launch a ball of mass m. When pulled back, the rubber strip extended delta x, and the tension is T. When launched, the ball is given the velocity v. So ball is coming out with velocity v. Describe in terms of work and energy transfer what happened immediately after the rubber strip is released to launch a ball. And see the weightage of the mark, it's of 4 marks. So basically what happened, so in terms of work done, and we have to use the term work done and energy. So first, what happened, there's a work done by the rubber strip because this rubber strip, when we release the ball will move. So initially there is a work done by the rubber strip on the ball. And which form of energy the rubber strip is having? The strip is having because the D form changes length, shape and size. So strip is having elastic strain energy. And when the balls start to move, the elastic strain energy transferred to ball as kinetic energy and internal energy or heat energy of the strip. Because not all of the elastic energy, practically it's not possible that ideal system is there that only one form of energy. So basically what happened, some of the elastic energy changed to thermal energy in the strip, and most of the elastic energy transferred to the ball as a kinetic energy. So how you will get these 4 points? The one mark when you mention work done by the strip. The second is the strip is having elastic strain energy. The third is it transferred to kinetic energy of the ball. You have to mention a ball. I did not mention here. And internal energy of the strip. But yeah, I mentioned the ball is there, kinetic energy and internal energy of the strip. The next part, when the tension in the strip is 3.5 Newton, the energy stored is 0.11. Calculate the extension. So how we can calculate the extension? We know the work done is equals to force into so the tension in the string, like this part of a string and this one as well. So what is the tension in this string? That is given 3.5. So this is 3.5 Newton and this is also 3.5 Newton. And the elastic strain energy is equals to the work done on the strip, and in this case elastic energy is equals to force into distance. But what about the force? As we mentioned earlier, whenever we have a spring or a string, the force is always an average force. So the total force, or the simple formula which you can learn for elastic strain energy, the elastic strain energy is half force into extension. That's a simple formula you can learn. So you don't have to use the average or calculate the average force. So elastic strain energy is half F into X. Now what about the force acting on this? A 3.5 Newton and 3.5 Newton. So total force which is acting on the ball, that is 7 Newton. So this total force which is acting is equals to 7 Newton. Elastic strain energy is half force into extension. The total, that is 0.11. It is half. The force will be, because I mentioned the tension in the rubber strip is 3.5. So 3.5 each side, so total will be 7, and multiplied by extension, we don't know, that we are finding. So it will be 0.11 multiplied by 2 divided by 7 will be the extension of this. So 0.11 times 2 divided by 7, that is equals to 0.031 meters. Is it clear how we find the extension, the change in the length? In question 6, in an investigation of a jump of a flea, the measurements were taken from a high-speed video. The body of a flea can provide a maximum power of 660 watt per kilogram. Each kilogram it can provide a maximum power of 660 watt. A flea has a mass of 0.7 milligram and it takes 0.85 millisecond to take from rest. Show that the maximum velocity of the flea is about 1 meter per second. So we want to show that the maximum speed or the velocity is 1 meter per second. So first we have to find the power for this mass, because this is 660 watt per kilogram, but the mass of the flea is only 0.7 milligram. And we know the formula that power is equals to energy divided by time. So in this case, it will be kinetic energy divided by time. So it is 660 watt per kilogram, 1 kg. But what about the mass of the flea? The mass of the flea is 0.7 milligram. So it will be 0.7 into 10 power minus 6 kilogram. Milli means 10 power minus 3 is there. But because we have to convert the SI unit of the mass is kilogram, so first we divide by 1000 to convert into gram, and then further divide by 1000 to convert into kilogram. That's why I write 10 power minus 6. So this will be x. So when we multiply, this will be a very small value, 660 times 0.7, which is equals to 462 into 10 power minus 6 watts. So that is the power developed by the flea. We have 4 point. What I did, I multiply 660 by 0.7, so it is 462 into 10 power minus 6. I did not multiply this, I just multiplied the numbers. So we have the power which is 462 into 10 power minus 6. Then the useful energy is the kinetic energy, which is 0.5. The mass of the flea is 0.7 into 10 power minus 6 multiplied by speed square, so v square. And that is divided by the time. So in the question, the time is given 0.85 milliseconds. So it will be 0.85 into 10 power minus 3 second. And when we solve this, it will be 462 into 10 power minus 6 times 0.85 into 10 power minus 3 divided by 0.5 into 0.3 into 10 power minus 6. And that is the value for v square. So to get the v, we'll take an under root, and the final answer will be 1.06 meter per second. That's the speed at which this flea will move, the maximum velocity. Is it clear, this question, that how we work out the maximum velocity using the power? And the energy is a kinetic energy, which is half mv square. Calculate the acceleration of the flea. So we have this, it started with rest. This is about the equation of the motion. So it started at rest. The maximum it reached as 1.1 meter per second, and time is equals to 85 millisecond. That is 0.85 millisecond. So 0.85 into 10 to the power minus 3. So acceleration is a change in velocity divided by time. So it will be 1.1 minus 0 divided by 0.85 into 10 to the power minus 3. So this will give us the acceleration of this flea, which is about 1250 meter per second square. Look, sometime you're not able to get the answer for the first part. Example, if this was an exam question and you try to get the answer but you're not getting a right answer, so what you can do, because for the second part we have to use the answer, so you can use the value which is given for the next part. So they accept this. That's the main reason that why they give this answer, because that you have to use in the second part. The next one, the measurement were repeated with many fleas. The average initial velocity of a flea at takeoff is 1.2 meter per second at an angle of 32 horizontal. Calculate the average horizontal distance the flea would have traveled. So now this part is related to projectile. So it is taking off with a velocity of 1.2 meter per second at an angle of 39 degrees. We need the range. So first what we do, we'll find the time to reach the maximum height. So velocity will have two components. There will be a horizontal component and the vertical component. The horizontal component does not change. It remains constant. So this will be 1.2 cos 39. And the vertical component, it decreases and it is 0 at the maximum height. Vertical component is 0. So using that, first we'll find the time to reach the maximum height, and then the total time of the flight will be the double to time to reach maximum height. And to get the range, we'll use the horizontal speed multiplied by the total time. So time to reach the maximum height. So whenever we use the height, we always use equation of the motion and vertical component. So V is equals to U plus AT. V is 0, U is the initial velocity, which is 1.2 sine 39 minus, or you can write minus 9.81 into T. So T will be equal to 1.2 into sine 39 divided by 9.81. This will give you the time the flea will take to reach the maximum height from the original position. But when you check the acceleration of the flea, because it's a related part, so that is 0.077 second. But that's the time to reach the maximum height. So what is the total time? It will be T1 plus T2. So the total time will be double or twice of 0.077, which is equals to 0.154. So we have the total time. Now to get the range. So range is distance, the horizontal distance, that is vertical horizontal velocity. The horizontal velocity is 1.2 cos 39 multiplied by the total time, which is 0.154. That will be the range, equal to 0.144 meter per second. Is it clear how we work out this question? It's a projectile question. So first we got the distance, the time to reach the maximum height, and then the total time will be the twice of it. The next part is actually related to the material topic that we will discuss later. That's fluid and materials. That's a next topic. So two students P and Q, they have the same mass, climb the mountain. They both start with the same vertical height. Student P took 2 hours to climb a shorter and a steeper route, whereas student Q, it took 3 hours to climb at a longer and a less steeper route. Which road describe the gain in the potential energy? So potential energy does not, energy or work done does not depend on the route. It depends on the starting position and the final position. So both are starting from same height. It means the potential energy will be same. But what about the power? The one which take more time means he developed less power, and the one which take a shorter time means he developed more power. So the power of the P will be greater than power of Q. So C will be the right answer. Is it clear? Discussion. So same thing, discussion can be a work done. So same answer will be there if they ask for a work done. Any doubt in this question? Then a spring is there attached to a wall. A 15 Newton force is there which is pushing, and distance moved. So always remember the work done. A student suggests that the work done on the block is 15 into 0.05. Suggests why this suggestion is not correct. Like students applied a force of 15 Newton and he moved the object to a distance of 0.05. So he suggests that I did a work done the work done on the spring is equals to the force 15 and 0.05. So student suggests that the work done on the block, he's saying the work done on the block is 15 into 0.05. Suggests why this is not correct. Basically, two reasons are there. That's just why it is of 2 mark. Number one, when a student try to push the block, it's not only pushing the block, there is a work done on the spring and the block, not only on the block. That is one reason why student statement is not correct, because if there was no spring, like example, this part, there was no spring, and the student said that I did a work done of 15 into 0.05, then he is right. But as you can see in the figure, there is a spring as well as the block. So in that case, the work done is actually on the spring and the block both, not only on the spring, that's or the block. That is one thing. And the second one, because the spring will also apply a force, that's called a tension. So spring will also try to push outward. So the resultant force on the block will not be equal to 15, it will be less than 15. So these are the two reasons. So the force on the block is not 15 Newton because the spring will also apply the force. So as the spring is also applying the force, that's why the force on the block will not be 15. Like if a spring is applying a force of 2 Newton, then the resulting force is not 15, it is actually 13. Is it clear, this question? 8. Any doubt in this question? Then the next part, when the spring is compressed to 0.06, the tension in the spring is 18 Newton. The mass is held in this position and then released. The block move on the frictionless surface. Calculate the velocity after it loses a contact. So basically the elastic strain energy, now we are not applying the force, we compress the spring. So when we compress the spring will push this block outward and the elastic strain energy converted into kinetic energy, and using that we can work out the speed. So we can say the elastic strain energy or the kinetic energy is equals to the elastic strain energy, and elastic strain energy is always half force into distance, because whenever a work done on the spring or the strings, the force is always the average force, it's not the constant force, because the force continuously vary or change. So elastic strain energy will be half force into extension, and the kinetic energy is half mv square. So this half will cancel with half. The mass of the block was given, which is 0.4. V square is equals to the force which is applied, 18 multiplied by how much it was compressed, 0.06. So V square is equals to 18 times 0.06 divided by 0.4, and we take a under root. So speed will come out around 1.64 meter per second. Is it clear? Discussion. So energy transformation is always there. We always use the principle of energy transformation. So these are questions related to topic work, energy and power. And the next session will do more questions related to this topic. Any question or a doubt related to the class today? So I'll end the session and share this with you.